So the next unit that we'll look into for chapter 13 is the structure and function of the heart. So to begin, let's look at a little brief overview of cardiac anatomy and their muscle cells. So these are going to be striated just like skeletal muscle was, and so these are going to be defined by a sarcomere, so from Z disc to Z disc. And so it also has the thick filaments of myosin, and then which are still considered to be part of the A band, and then the thin filaments, which are going to be the actin molecules. Okay, and so these are going to be short branch cells, and they are going to have a Y shape to them where we have the branching, such as within this picture. These also will only have one nucleus, where a skeletal muscle had multiple. And they also have a special structure, which are the intercalated discs. Okay, so these and the union of these intercalated discs are what form a functional syncytium, which is so that they are allowed to contract as a unit. Okay, and so these are held together by different desmosomes, and so that they have a mechanical unit when they contract for the contractility of the heart. And then there's also gap junctions that we find within the intercalated discs. And so here we see these little gap junctions. And so these allow for electrical activity so that they will contract as a unit as well. And so just like with skeletal muscle, we have the sarcoplasmic reticulum that stores excess calcium, because calcium is going to be very important for the electrical activity of the heart and is going to be a predominant ion, okay, in terms of depolarization. So now let's look at the coverings and layers of the heart. So the heart walls are composed primarily of spirally arranged cardiac muscle fibers, and we have three different layers for the fibers. So the first one is the endocardium, and then this is primarily by endothelium, and so it's going to be very small or thin layer and is going to be most internal towards the heart. Then we have the myocardium, and so the myocardium is going to be spirally around the circumference of the heart. So with ventricle contraction, we have the apex is going to be, here's the apex of the heart, is going to be pulled up in like this ringing effect for efficient blood flow. And then lastly, we have the epicardium, and so the epicardium is going to be the superficial most layer of the muscles themselves. So then the heart is enclosed by a pericardial sac, and so within this pericardial sac or pericardial cavity, what we have is serous fluid, and so that allows for prevention of friction. So when we have excess fluid in this pericardial cavity, what happens is that the ventricles can't contract and relax and fill due to excess pressure, and then thus that means that less blood is going to be pumped out throughout. And so lastly, all of this is held together to the large vessels by the fibrous pericardium, so that the heart is pretty much localized even with the massive contractions that it undergoes. All right, and then to review, so we have 4 chambers within the heart. So here we have the right atrium, and then we have the left atrium, and these are going to be more superior. And then we have the right ventricle and the left ventricle, which will be more inferior. So we also have 2 systems. We have the pulmonary system, and so that typically is associated with the left side, and then so the right side is going to be associated with our systemic circuit. Okay. So the ventricles also have these papillary muscles, which, let's see in a different color, right here, papillary muscles. And so these are going to project into the chamber from the apical region, and they are going to connect to the atrioventricular valves, okay? And so the atrioventricular valves also have these fibrous structures here, and so these are the chordae tendineae that are attached to the papillary muscles so that they allow for snapping the vessel the valves open and shut when they are in their respective diastolic or systolic conditions. Okay. All right, and then so a big thing too is that the left and the right ventricles pump the same amount of blood. However, the left side performs more work because this is pumping out blood to our systemic circuit, whereas the right side is undergoing or has less work because it has less resistance and less pressure because it's going out to the pulmonary circuit. So when we look at the valves, the function of the valves is to prevent backflow. So we have two main types of valves. The first one is the atrioventricular valve, and then the second are the semilunar valves. So the atrioventricular valves, these prevent backflow to the atria, okay? And so each valve contains a number of thin leaflets or cusps that are going to be connected by a fibrous ring. Okay, so here's an example of that fibrous ring. And so when they open and close, they can in a passive manner. When they close, there's a backward pressure, though, that pushes the blood back against them and opens them into a forward movement. Okay, so here we have an example of blood is coming in and then there's increased pressure, so that increase in pressure is going to have that blood flow passively into, say, that ventricle. So why with this, what we have is an increase in pressure that's building up. However, there's low pressure here, and so that is why we have these valves that are closed at that point. Over time, when there is going to be less pressure in, say, the atria than there is in the ventricle, what that allows for then is that these valves will now close, and due to the increase in pressure, now this will open that valve so that blood will go from an area of high pressure to an area of low pressure. Okay, and so there is a forward gradient that allows for the prevention of backflow. And so this is true for both the AV valves, the atrioventricular valves, and then also for the semilunar valves. And so the purpose of the semilunar valves, which we have here, is to prevent backflow into the ventricle. So we do not want that, right? We want blood to go up into their respective vessels. So here are the mechanisms of valve action. So for a valve to become open, when the pressure is greater behind the valve, then the valve will open under normal conditions. So then we have high pressure here, and then here we have low pressure, okay? And so that allows for that forward movement. So now when the valves close, now this chamber has a low pressure, and then this chamber has a high pressure, and so we have the blood that's forcing that valve to close. And so that allows for prevention of backflow into the chamber that the blood just came from. And so this allows for that one direction of blood to flow through. So here we have an example of the different valves. And so here the right AV valve, also known as the tricuspid, and then here we have the left AV valve known as the bicuspid because of the amount of fibrous inserts that it has. So here tricuspid because 3, and then bicuspid because there are 2 here. Now both the aortic and pulmonary semilunar valve have the same shape. They kind of look like little moons and have this 3 fibrous structure to them. And so again, the version of the AV valves is prevented by tension of the leaflets by the chordae tendineae, which are going to be these fibrous strings here. And so the AV valves are going to be in between the atria and in between the ventricles. And then so the papillary muscles will also help to contract and to snap shut those valves when we have the blood flowing through them. When the semilunar valves are swept closed, then their unturned edges fit together and then lock into place. And so this creates a leak-proof seal even though there are no papillary muscles or chordae tendineae to help with that. And it has to do a lot with the structure of those semilunar valves. So what this means for heart sounds is when the valves are closing. So we have the S1 sound, or the first heart sound, and this is what we term as lub. And so this occurs when both the atrioventricular valves snap shut, okay? However, we have then the opposite effect of the semilunar valves here, which are going to remain open. Okay, and so this is going to be the start of systole. S2, heart sound, is typically known as our dub sound. And so this is now the closing of those semilunar valves that we have. And so these are simultaneously for both. But then here we have the opening of the AV valves. And so this is now the end of systole. So systole is going to be when we have, is in between S1 and S2. And so this is going to be between lub and dub. And that is for ventricular contraction, okay, for the to the rest of the body. So then from S2 to S1, from the dub lub, what we have is diastole from the atria to the ventricles. So when we talk about systole, so that means contraction, diastole would mean relaxation.